Greetings, FRC Robotics Engineer Kevin O'Connor here with a video for you on the Driver Station log file viewer. So in this video we're going to go over a couple logs in the log file viewer itself, and then I'll talk about some things on the screen steps page because I've managed to misplace some of those logs for things like FMS connection and what some logs look like from connectivity issues. So the easiest way I find to open the log file viewer is from the driver station. Just click this view log file. I'm not going to do it now because these log files I have open are from a custom folder. But you can also find it in program files, x86, as you can see on my 64-bit machine, FRC driver station log file viewer. And you should have only one here. As you can see, I have an old one with a very old date with the spaces. You should just have this one with no spaces unless you have old software floating around. So double clicking this would also open the log file viewer for me. This is the driver station log file viewer. These are a couple logs of the faster PDP logging. Here are some tests of it performed by someone at CTRE. So you can see up here in the top right, we have the different plots. I've found that sometimes by default, the things that these open up with, like sometimes when you open up the log file viewer, this will be unchecked, but that plot will be showing. So if you really want to be sure that it's only showing what you expect, I would generally sort of check and uncheck all the boxes. And so now we see that we have an empty plot. So we can show robot mode just by itself. So robot disabled is gray here. So you can see this top plot is the robot reported mode. So if we hover over, we can see in the bottom left it says robot disabled. This bottom continuous line is the driver station requested mode. So we can see DS disable as we hover over it, and then DS teleop. The robot followed into teleop. So in this graph, these are as you expect. The robot mode reported matches the driver station mode requested. And this code was either using one of the iterative templates or command-based templates in either LabVIEW, C++, or Java. So LabVIEW, all the templates are iterative. C++ and Java, either the iterative template or the command-based template. If you use the simple template, unless the team manually calls the observe user program methods, you'll just get a single dot right at the transition, and you won't have the continuous pattern here. So this continuous pattern is a bunch, as we zoom in, a bunch of little dots that appear every time the robot code loops through once. We can press this auto scale button to get right back. Every time the robot code loops through, it plots a dot here. So this code was looping through as expected. The big thing the robot mode can help you diagnose is if a team has, say, a loop that doesn't exit properly in autonomous or something like that. They may, a log from their match may show disable, and then the DS goes to auto and the robot follows it, and you'd have a little green, set of lines here. And then the DS will turn blue. It'll actually go gray for a little bit and then turn blue when the match switches to teleoperated, but the robot won't. The robot would just stay green because they have some thing that's keeping them stuck in auto in iterative, or they would just have the green dot and you'd never see a blue dot at the transition if they're in the simple template, which is actually where it's more common to have these loops. So that would be a reason why you'd be looking at this robot mode, one reason. But just in general, if these don't match, that's something to be very suspicious of. They've either really modified the template code or their code's doing something that it shouldn't be. So start searching around for loops and things like that that are keeping them in a mode where they shouldn't be. So that's robot mode. We'll get rid of that. Basic. All right. This yellow plot is showing us our battery voltage, which is sort of hopping down in steps here. We'll see why in a little bit. Our Rio CPU percentage is pretty normal. These red spikes, they are a little anomalous, but they're pretty short. They're still well below 100%. They're nothing I'd really worry about. This may be a Java program that's doing garbage collection or something like that. CAN usage percentage is plotted here at the bottom. So this is captured in the driver station log. The estimated percentage of the CAN bandwidth available that's being used. So that's again plotted on this 0 to 100 scale shown over here to the left. So we're using about 7.5, a little bit more percent of the CAN bus in this log. So that's perfectly fine. No problems with that. The basic also contains some plots here of events. So these are all the events that are getting logged. So in this case, as I hover over, I can see that most of these are print statements, and this one here from the beginning is print statements from the code as well. But errors or things from the driver station may pop up here. Errors will be shown as red dots. These print statements show up as yellow ones. Brownouts could show up here as orange dots. Things like that will all be shown under basic. So we'll go ahead and get rid of that. Comms, trip time in green. Our trip time here looks good. Drop packets in orange. This bar at the very beginning you don't really have to worry about. This is a little anomalous that we drop some packets here. If we overlay this with basic, we check and see if this lines up with anything. It does line up with some battery voltage spikes here, but in general, this might just be some process running on the computer. This isn't a ton of missed packets. I wouldn't really worry about this too much, but just keep an eye on it. See if you see something similar like this in other logs from the team, if you saw this in one log. So that's all good. Power. So this will show both the voltage plot and any current plots. So this is channels 0 through 3. You can go to plots to enable plots individually as well. So all the things we've talked about, are individual plots in here. So brownouts, did we have any? Nope, we see no orange dots when we enable that. So we can go ahead and uncheck channels we don't have, and we can see that this is PDP channel number 3. So this is the current draw plotted versus the voltage. So we can see as the current draw increases, we've got this stepped current increase. We've got these stepped voltage decreases. Right up until we get up here. So here we see this spike in current draw. This is where the motor was stalled in some fashion, I would presume, because the current draw massively increases right up until it massively decreases and the battery voltage recovers. So this is either the motor being stopped abruptly or stopped abruptly because, in this case, the breaker tripped. So these spikes right here, both spikes and then the drops. The drops are where the breaker tripped, and so the battery recovers. This could also happen across all channels for a brownout event, though you would see the orange brownout plot dot appear. Or it could be that this motor was stopped. So the PDP current measurements are much quicker this year, so you're much more likely to capture these types of events. They're done every 20 milliseconds. It is asynchronous, so you may not actually get a reading every 20 milliseconds, depending on how the thread on the RoboRio packs them up as it's sending back to the driver station. But they're still much quicker than they were last year, so you're much more likely to catch events like this. The PDP current logs can be very helpful in terms of diagnosing robot issues. So I can tell you an anecdote from my team personally. One, I don't have the log file here, but an issue that we were diagnosing a couple weeks ago, the robot was not driving straight, and one of the sides of the drivetrain was sounding very odd. So I wanted to see what the differences were in the current measurement. So I opened it up here. Ours were on channels 0 through 4, so I checked 0 through 4 for the current, and I only saw 2 plots. So that seemed odd. I rechecked the robot wiring, and yep, it was definitely channels 0 through 4, and there were definitely only 2 plots. So what we did is we put the robot up on blocks, we ran it, and looked at the lights on the talons, and our talons are upside down, so this is why we hadn't noticed this without explicitly trying to do it. And we saw that only one talon on each side was running. And this made the robot not drive straight and sound very odd because of the talons that weren't running, we had a second issue where one of them was in brake and one of them was in coast. So the side that was in coast sort of limped along okay on one motor. The side where the second motor controller that wasn't running was in brake did not run quite so well. So we dove into the code and checked out why only one side was running and figured that out, found a bug in the code. But the thing that pointed us down the right path was the PDP logs showing us that only 2 of the talons were drawing current. The other 2 were completely zero. So PDP logs can be very useful for diagnosing issues related to current draw, whether it's a brownout issue, whether it's a mechanism that's drawing more current now than expected, or tripping a breaker, wondering if a breaker tripped, things like that. You should be able to ascertain a lot of that from these PDP log information. The last thing I'll go show you here is the event list. With the driver station console feature this year, now all of these prints from the robot code get logged here. So here we can see some from network tables, like right when the program starts up. And then this is that whole blob near the end. So you can see these sort of run into each other, which is a little unfortunate. So we see the exception. The next one here is the whole stack trace. And doesn't quite, oh, here. So partway through, you can see that we start the next exception. So this exception is getting thrown a bunch of times in a row. And unfortunately, they sort of run into each other. But you really only need one to debug the issue. So we can go here. We can see that the stream is closed at timerthread.run, timer main loop. So somewhere we have this buffered writer that's trying to write to a closed stream inside a thread that we're calling in a timer. So this should give us enough to go dive into the code and track this down. This one's a little bit tougher than if it was just somewhere, you know, in their teleop method or something like that. You'd get this nice, pretty stack trace that would tell you exactly where to go look. But this gives you enough to sort of, we can go to robot.java line 78 and figure out what is in there, what timer thread that is, and track down where we're writing to this file that's closed, this stream that's closed. So C++ won't give you quite as much information on these exceptions. This Java one presumably was non-fatal. It must have been getting caught and reported by something because it didn't close the program. It just kept getting thrown. But if their code is crashing, you could see that as well with Java exceptions being written out here to the driver station log. You can also see things, info, DS laptop CPU percentage, and battery can sometimes be helpful when diagnosing robot issues. And then you see in yellow here the warnings that the driver station has written. So this is the default filter. We can also go to all events and time, which shows some additional stuff. Right now it shows some annoying stuff like this tag version, which has to do with how we're writing things on the RoboRio. It's not particularly helpful, but it does show you now this time entry in here as well. And all events, all info doesn't look a whole lot different. So that's, other than these buttons over here, which we haven't covered, auto scale we sort of did, that puts the whole log here. Match length will zoom in to approximately the length of a match, and then you can scroll around and find the match start and see the log of the match. The voltage filter will filter out voltage and I think maybe 1 or 2 other plots when there's no connection to the robot. So on this one we were connected the whole time, it doesn't do anything. But sometimes you'll have these erroneous voltage readings. If you have a perfect flat line while the robot's disconnected, the voltage filter should remove that. And larger points, let's go ahead, hop back to groups, not comms, show basic. So we've got all these little points here that are showing all of our events. If we go larger points, thought that made them larger. All right, maybe it's just for these points up here. But if you have a team that's using simple, like I mentioned, and you can't see the point where they make their transition, larger points may blow it up and help you see the, the first call of their teleop method when they make that transition, or their first call into auto when they make the transition there. So I'm going to go ahead and close this, and we'll take a look, and I'll talk about some of the things on the logs on screen steps. So finding logs from events. So you'll see when the driver station connects to FMS, you'll see an event get logged that shows this FMS connected and what match it was and what time the field sent over that it thinks it was. So this should help you track down what log belongs to a particular match, even if the driver station computer is in a different time zone or has a clock that's way off. You should still be able to track them down using this FMS connected identifier. So you can see here the times were right on, so this one was easy to find, but sometimes the driver station clock is very different than the time at the event. Excuse me. So the FMS connected event will help you track down matches for logs for matches. So this is a log of a match that on FMS Lite or FMS Off Season now, as it's called. This is a normal match, and these are from an older version of the log file viewer, but it's basically the same as if I had the PDP info turned off. So CPU percentage, we've got our modes up here. We see what we expect, that the robot's following the driver station modes. And in this case, we may have been tethered in or something because we have 0 trip time, no missed packets at all. So this is a perfect match. No issues. You can see here a couple warnings that are logged right as the driver station boots up. So a joystick being disconnected. The custom I/O one you won't see anymore because we got rid of that. But in general, a few warnings like this right at the beginning when they first connect can happen. Or things like robot code not running yet. It may say robot code's not running. That could be because they just connected. All right, so we're going to blow up this picture of disconnected from FMS. So if your driver station is disconnected from FMS long enough, it may split into 2 logs, which is what has happened here. So on the left, you can see the first log, and we disconnect from the robot. And then we have a second log here. And the way that you could tell is, number 1, that the log file got cut here. Number 2, in this second log file, we come right up in teleoperated. We get this FMS connected message, and then we're in teleoperated right away. So that tells us that the driver station computer disconnected from FMS. You could also see this in the FMS logs. The FTA or FTAA could help you see that the driver station disconnected from FMS in the FMS log as well. So this is like an Ethernet cable without a tab on the field, or an Ethernet jack on like a classmate or something that's been broken and doesn't retain the cable. That's the kind of thing that causes that typically. So this next log is a RoboRio reboot. So we can see when we disconnect here, we're gone for a period of time, we come back up and we get this message that says second since reboot, and it's a very low number. This is what tells us the RoboRio rebooted, because this message that's logged is into the match quite a ways, which we could see based on the timestamps. And it says we've only been up for 3 seconds. So this is more than 3 seconds into the match, more than 3 seconds since we should have, powered up our robot, but the RoboRio's only been up for 3.5 seconds, so we know the RoboRio rebooted. Here's a quick log that suggests an Ethernet cable issue on the robot. The reason for that is these radio lost and seen events. So we lose the radio and it comes back. And we can also see the ping status events where the radio is still pingable, but the Rio is not pingable. That suggests that either the Rio rebooted or we have Ethernet connection issue on the robot, but when we come back, we see time since reboot, 1,809 seconds, way longer than our match, so the RoboRio didn't reboot. So this is probably an Ethernet cable issue on the robot. Radio reboot. So this is a log of a radio reboot. The big thing that we see here is, again, that the RoboRio has stayed up. Our robot radio ping goes bad. Sometimes you may get, if it's working correctly, you'll get the radio lost events from the RoboRio after reconnect. I'm not showing them here in this log. But the big thing is that the radio ping went bad, and you'll see it for the typical time frame of the radio reboot of 40 to 50 seconds or so for the radio to reboot and reconnect to the field. So those are some quick diagnostics to do with the driver station log file viewer. As I said, you can also see some of the console messages this year, so it may be even more helpful, as well as the faster PDP logging time. So make sure to let us know if you're getting good use out of those features, or if there are additional things that you want logged here that we don't log yet. We'll certainly be willing to consider those for next year. So good luck interpreting your PDP logs and driver station logs.